Hello and Namaste. In continuation with this solutions of different self-observation slides, we are going ahead with the maxima and minima of a function part 2. Under this, we have been given this show that the function f of x comma y x cube plus y cube minus 63 times x plus y plus 12xy is maximum at minus 7 comma 7 minus 7 and minimum at 3 comma 3. So we'll be just going ahead with the detailed solution of this particular question in the today's session. So in this particular question, if you'll observe here, we have to have the dou f upon dou x, that is 3x cube minus 63 plus 12y is equals to 0. Dou f upon dou y, that is 3y square minus 63 plus 12y is equals to 0. That is just a simple differentiation of the function f with respect to x with respect to y equating with the zeros. Immediately after dou f upon dou x, we can just go ahead with the r, that is dou square f upon dou x square, which is 6x. Then taking dou f upon dou x and differentiating that this particular equation with respect to y, we will get this as 12y. Similarly, dou square f upon dou y square, that is t, is equals to 6 times y. Then, as I have told you that dou f upon dou x is equals to 0, so we have taken it here, that is dou f upon dou x is 0, that is 3x cube minus 63 plus 12y is equals to 0, which gives us, taking 3 out from here, this will be giving us as x square plus 4y minus 21 is equals to 0. So far this is equation number 1. Dou f upon dou y is equals to 0, that is 3y square minus 63 plus 12x is equals to 0, which is y square plus 4x minus 21 is equals to 0, which is the second equation. Suppose if you'll observe here, if we just go and do the simultaneous equation, we are not going to get any single variable. So if we will go ahead with the equation number 1 minus 2, that will gives us here x square plus 4y minus 21 is equals to 0 minus y square plus 4x minus 21 is equals to 0. So if you're subtracting these two equations, we are going to get it from here as this 21 will plus minus 21 will go off. We will remain here with x square minus y square, and this would be minus plus 4y minus 4x is equals to 0. Minus 4x is equals to 0. That would gives us here, this particular equation would gives us here, this is nothing but, now x square minus y square will write down x minus y into x plus y. Then we are taking, because we need to have this something with the x minus, right? So let us take this minus 4 out. If we are taking minus 4 out from these two terms, we are going to get it x minus y is equals to 0. Let me just make some space over here. That is, this is nothing but, so x minus y is out from these two terms, two different terms. That would gives us x minus y is equal into x plus y minus 4 is equals to 0. So we are getting here two things, that is x is equals to y. So we are getting x is equals to y here. And the second thing is x plus y minus 4 is equals to 0. So these are the two equations or two solutions we are going to get it. Now let us consider the first branch of this. So we are getting the first, that means this is the first branch. Say this is a first, this is the second branch of this particular equation. So first branch, x is equals to y, would gives us here, suppose this particular x is equals to y, we are going to put it here in this, say for 1, first equation. So what is that first equation? That is x squared plus 4y minus 21 is equals to 0. So if we are putting x is equals to y here, we are going to get it x squared plus 4x minus 21 is equals to 0. That means we are going to have this is nothing but x plus 7 into x minus 3 is equals to 0. That means we are going to get this from here, x is equals to minus 7 and x is equals to plus 3. So we are getting two values here, x is equals to minus 7 and then plus 3. So that means what, again from this x is equals to y, this particular branch, we are going to get the two values again. So suppose these are the two values. So x is equals to 7 and x is equals to 3. Now if when x is equals to minus 7, Y would be, so because x is equals to y, obviously this y is equals to minus 7, because x is equals to y in this particular branch. And similarly, if x is going to be 3, y has to also be 3. So we, from here we got the pair minus 7 comma minus 7 and 3 comma 3 as the, these are the two different pairs we got it from this particular equations or particular branch of this particular solution. Let us go ahead and solve this x plus y minus 4 is equals to 0. That means what we are going to get it from here, y is equals to 4 minus x. From here we are going to get it y equals to 4 minus x. Let us say the same example or same particular this equation here, that is x square minus 4y minus 21 is equals to 0. That means x square minus 4 into 4 minus x minus 21 is equals to 0. That means it is nothing but x square minus, we are going to get this equation as x square minus 4x minus 5 is equals to 0, because it's a minus 16 and this is minus 21. So we are going to get it here. So we are going to get this particular equation, just a minute, it's of plus 4y, no? Plus 4y. So it is 4, okay, this is nothing but minus 4x, and this is plus 16 minus 25, 21 will give us minus 5, and therefore if we just have this roots of this is nothing but x minus 5 into x plus 1 is equals to 0. This gives us two values. This gives us two values. X is equals to 5 and x is equals to minus of 1. Now whenever we have got this x is equals to 5, y, what would be y? We have to take this x is equals to 5, put it here, in this x plus 5 minus 4 is equals to 0. So when x is equals to 5, we are going to get it y is equals to minus of 1. Similarly, when we have got x is equals to minus 1, we are going to get it y is equals to 5. So we got the pairs from here as 5 comma minus 1 and minus 1 comma 5. So we got in short this 4 pairs here in this case. So minus 7, 3, 3, 5 minus 1 and minus 1, 5. So these are the 4 different pairs we have got it from this particular equation. Now we have to take a call which all pairs would be a stationary point and at what point we are going to get the maximum point or a minimum point. So here we have got 4 possible extremum points which are for of f of x comma y as minus 7 comma minus 7, 3 comma 3, minus 1 comma 5 and 5 comma minus 1. This is also one of the hint I have given you for this particular example. Now let us go ahead and solve this particular thing, that is what are these, nothing but the pairs over here. These pairs we are solving it for the stationary pairs. Now we have got the 4 pairs. Let us go ahead and check it with the minus 7 comma minus 7. So we are considering this as a first pair. Whenever we have got this x as minus 7, y as minus 7, what should be r? R in this case would be minus, because r is 6x, s is 12, t is 6y. So these are the values we already got it in the previous steps. Then we have to take a call what should be the value of rt minus x s square, whether it's positive or negative. If it is a positive, then we can say that yes, extremum value exists. If it is negative, then we have to exclude that particular pair for the extremum or for the extremum value. So this is minus 42. Then this is 12 because we do not have any x and y in this s. So throughout this particular s would be 12 everywhere. So that would be there. T is again it is minus of 42. So if you'll observe rt minus s square, we are going to get it as 1620. Please do check, and if at all something change is there, let me know. So it's 1620, which is going to be 0, greater than 0. That means what? We do have some point extremum or minimum at this particular point, minus 7 comma minus 7. Then at 3 comma 3, this r would be x is equals to 3. So 6 3s are 18. So it is nothing but 18 here. This is, as I have told you, it would be 12 only. Again it's 6y, that is 18 here. and this RT minus S square we are going to get it as 180, which is again greater than 0. So that means what, there is some possibility of some extremum or minimum at this point also. What about the point minus 1 comma 5, minus 1 comma 5? So at that time R would be minus 6. Then this it is because X is minus 1, so it's 6, yeah, correct. So 12, this is 6, 5, 30. Then and this is RT minus S square, we are going to get it as minus 324. So we got this as 0, less than 0. That means what, we are not accepting this particular pair for extremum or minimum value. Similarly, the next pair we have got it as 5 comma minus 1. At 5 comma minus 1, what is R? R is 30. This S is 12 because it's only the 12 over here as S. And this T is minus of 6. What is RT minus S square? We have got it as minus 324. Again, it's less than 0. That means this pair 5 comma minus 1 also we are going to reject for the possibility of any extremum value. Okay, now we can have the look at this R in this for the 7 comma minus 7 comma minus 7. So at minus 7 comma minus 7, we have got it here, we have got it R, or you can say or T, both of them are negative. If both of them are negative, that means what, this gives us here the function f x comma y is maximum at minus 7 comma minus 7. This is what we have to show it here in this case. Again, at the point 3 comma 3, we have got R, or just a minute, or T is greater than 0. If they are, both of them are greater than 0, that means f of x comma y is minimum at 3 comma 3, and you can easily find out the values of those particular points. But yes, in this particular question we have been asked only to find out, or only to show that this minus 7 comma minus 7 is maximum and 3 comma 3 is minimum for this particular given function. If you wanted to have the value for this particular function, you just take the value or the function of f of x comma y, put x is equals to minus 7, y is equals to minus 7, you will get the value of f of x comma y. What is the maximum value, and same way what is the minimum value of this particular function. Okay, so this is all about this particular question, which is the self-observation slide of this particular part 2 of maxima and minima of a function. So this is what all about this this particular self-observation slide. Thank you so much. If you have any query, let me write down in the comment section so that you can have I can have a particular output or particular feedback for this particular question. Thank you so much. Happy learning.